Hello everyone, welcome to Code Crafters Lab. So now we'll try to see if there are any better approaches to this particular problem of finding GCD out of two numbers. So till now what we have seen, we have ran one loop from I equal to 2 to minimum of n1 n2. We know why we have checked this, right? But can you say, like, let's say we are running one loop from 1 to 40, right? If 40 is the minimum, or maybe 20. Let's take this particular example where n1 equal to 20 and n2 equal to 40, right? So my 1 to 20, so there are numbers 2 3 4 5 till 19 20, right? In this particular case, my common divisor between n1 and n2 lies here, right? But I am checking from this side to this, right? There can be multiple divisors also. This one is divisor, this one, maybe this is also divisor, but what we want the last one. That's why we are calling it as a greatest common divisor, right? So if we say we are iterating the loop from the backwards, that can be a scenario. Yes, that can be possible. And why we are doing it in that way, we can avoid these many iterations, right? If we are doing it from backward, we know minimum of the n1 and n2. Till that time we have to iterate through the loop, right? That many iterations we need in the loop, right? So if I am traversing from backward, so first whatever I get is the greatest. Yes, it is the greatest. So what we have to do, we have to change this for loop to how it will look. Maybe in GCD will be same. One can be always a GCD. Then for I equal to mat dot mean of n1 n2, and then I is greater than equal to 2, right? And I minus minus. After that what we'll do, we'll do the same condition. We did it here, right? It will be a same condition. We'll paste it here, but there will be one change. What we'll do, we will break this. What we'll do, we will break this for loop here, because whatever the number that we get first, which is a common divisor out of these two, is the greatest one, right? We will avoid other iterations, right? This is like a optimal solution for this. Not optimal, but a better one than the previous one. We'll return here GCD. And what is the time complexity for this? It will stay same, because in worst case maybe we have to traverse through the all the numbers of minimum of n1 n2. Till that time we have to iterate through the loop, and SC space complexity is O of 1 only, right? So in the next lecture we'll try to find some optimal solutions for this particular problem. Thank you for watching.